Okay, this is 2.4, B as in Bravo, College Algebra. I'm on page 142. This is the graphical solution of linear inequalities. We're going to look at a couple different methods, the intersection method and the x-intercept method, and then we're going to do double inequalities and be done. I'm sorry for the noise in the background. I am at my cabin and I've got the generator on. So anyways, my wife is drying her hair, so that's why the extra noise, so I apologize for that. Anyway, the intersection method on page 142, they use, or their explanation here is using a graphing calculator, and I'm going to do it without the graphing calculator just so you learn the other way. So we have a linear equality with two parts to it. So let's go ahead and solve this. We're going to subtract 2x from both sides to get the x's together. Subtract 2 from both sides, so we have 3x is less than 4. Divide by 3, divide by 3. Notice we do not change the direction of the sign because we did not divide by a negative. We divided by a positive 3. So x is less than 4/3. So that is the inequality. And if we want to write it in interval notation, it would be negative infinity 4/3. It does not include 4/3, does not include infinity. Okay. And if you wanted to solve this graphically, what you would end up doing is you would take each of these and split them up and put y equals 5x plus 2 and y equals 2x plus 6. And you would graph each one of those. So if we graphed 5x plus 2, you would get something along that line. And if you graph 2x plus 6, you would get something along that. And this point of intersection then would be your 4/3. And what you would do is you'd find out what your y value is by putting 4/3 in here. And that would be 8/3 plus 6, or 8/3 plus 18/3, which would be 26 over 3. So your y value would be 26 over 3. So this place right there, that point, would be the point 4/3, and then your y would be 26 over 3 if you wanted to graph the intersection point. Okay, so graphing, all you're doing is setting that equal to y, setting that equal to y. Graphing it where it crosses is where your solution is. Okay, so once you find your x value, then you just plug it in here into this one or this one. You're going to get 26 over 3 regardless, and go from there. Okay, we don't use this graphing method very much. I'm not really too terribly concerned that you get it down exactly. I think there's only 2 problems in the whole homework assignment that go over that, so you should be okay. All right, so the intersection method of solution, example number 4, we have 5x plus 2 over 5 is greater than or equal to 4x minus 7 over 8. All right, so that using the intersection method, again, all you do is set this one equal to y and this one equal to y, and go ahead and graph it, and you get a graph that kind of looks like that. And you're going to be able to find x and then find y, and at that point, that intersection is the solution. Okay, so let's go to the x-intercept method. At the bottom of page 143, they give us the steps, in order to solve for the variable x. So first of all, let's go ahead and write the problem down on the next page, and it gives us 5x plus 2 is less than 2x plus 6. Alright, so the first step they say is to rewrite the inequality with all non-zero terms on one side of the inequality and combine like terms. So pretty much what they're just saying is get 0 on one side and everything else on the other. So bring the 2x over, bring the 6 over, and make it 0. So this is going to give me 3x, this is going to give me -4, and that's less than 0. Okay? Then it says graph the non-zero side of the inequality, which is this one. You're going to graph that. Find the x-intercept of the graph to find the solution to the equation, and you're going to be able to find the x-intercept because it's just where the line crosses the x-axis, and use the graph to determine where the inequality is satisfied. So let's quickly graph this. My y-intercept is -4, and my slope is 3 over 1, so it's up 3 over 1, and that gives me a chance then to draw my line, which isn't going to be real perfectly straight, but that's as good as I can go freehand. So notice my x-intercept is here, a little less than halfway between 1 and 2, and the book gives us the x-intercept as being 4 over 3 is where it's saying it crosses the x-axis. So let's look at our equation here, our inequality. 3x minus 4 is less than 0. So that means at what point is 3x minus 4 smaller than 0? And that will be when my line travels below my x-axis here. Okay? Alright, is less than 0. You can really put like a y there, and if you do that, if you put a y in for 0, then you know that y is, or that 3x minus 4 is below this, because if we go up, y has a value above 0, whereas if it's below, 3x minus 4 has a value below y is 0. Okay, so it's everything down here. And if we want to write it in inequality form, it would look like that. X has to be below this 4/3. We could write it as -infinity 4/3 and put the rounded one because there's no less than or equal sign there. And then we have the graph there on the right hand side. Alright, so example number 5. I'm not going to go into a lot of detail on. For one thing, the book is very vague in their explanation here, and the graph especially, they didn't label the graph, so you don't know whether the horizontal or the vertical is what. I mean, I'm assuming the horizontal is your humidity and your vertical is your temperature, but it doesn't make any sense at all. So we're going to just kind of skip the part of the graph, but I do want to go over the equation, or the inequality. During a recent summer, Dallas, Texas endured 29, okay, I don't care about all that. Alright, on many of these days, the combination of the heat and humidity made it feel even hotter when it was. When the temperature was 100 degrees, the apparent temperature, and they use A for apparent temperature, depends on the humidity H, according to the formula, 90.2 plus 41.3 H. Okay, so that particular equation, my H doesn't really look very H-y, that particular equation is taking the temperature and the humidity and putting them together to determine what the temperature actually feels like with the humidity. Okay, it says for what humidity levels is the apparent temperature at least 110 degrees. Okay, so we want to know when this is going to give me a temperature at least 110 degrees. So either equal to 110 degrees or greater than 110 degrees. Okay, this, what do they call it? Apparent temperature. Well, they tell us that we're trying to make sure that A is greater than or equal to 110 degrees. Okay, so instead of using A here, we're going to put 110 in its place. So 110 is less than or equal to 90.2 plus 41.3 H. All right, and if we go back to our little box there, bottom of page 143, it says rewrite the inequality with all non-zero terms on one side. So we're going to make it set up equal to 0. So we're going to make that 0, so we're going to subtract 110. So we get all the numbers on the right hand side that we're going to use and the 0 on the other. So that gives me, that is going to be a negative 19.8 plus 41.3H. And you could write those, switch those around. Some people might rather do this. Doesn't really matter. Okay, it just puts the minus sign there instead. All right, so from there on, we can draw the line and then figure out at what temperature or what humidity level the temperature, what is it called again? The apparent temperature is going to be greater than 110 degrees. Okay, so we graph that and then we can look at that and find out when that's going to be greater than 110 degrees. Okay, so what we're looking for is a number for H, or numbers, which in this case there's going to be an awful lot of numbers that will make this apparent temperature greater than 110. And if you put it in your calculator and graph it, it will give you a graph, or you can graph it by hand, which is a little tricky when you're dealing with the decimals. But one of the things to remember is the humidity level has to be somewhere between 0 and 100%. Okay? It's not going to be higher than 100%. So it's going to be somewhere between there. And when we graph this, we find out that it crosses the x-axis at 0.479. So that's going to be less than or equal to the humidity, because that's what we're looking at. And it's got to be less than 100%. So if we have it in just decimal, it's going to look like that. If we want to put it in percentage, the humidity level is going to be somewhere between 47.9% and 100%, because if it goes below 47.9, the apparent temperature will not be 110. So it starts at 110 at 47.9 and will keep raising until it's at 100%, which obviously, that's going to be greater than 110 degrees apparent temperature. So the humidity has got to be somewhere in there. Okay, so when you have the graph, you can see that. And that moves us into double inequalities, which sound a lot worse than what they are. But what a double inequality basically is when you've got two greater than or equal to symbols. Okay, you've got three parts. All right, so for example number 6 talks about course grades. A student has taken 4 tests and has earned grades of 90, 88, 93, and 85%. All right, I'm just going to take a picture of this. And the reason I did that was to just give you a better idea of what we're looking at. And I'm going to finish this up on the next video now that I see we're 15 minutes into this.